So welcome back, guys. So I had something in my mind that I thought I would share with you today. So basically, if you have ever debugged any Microsoft Office application, you might have noticed there is no symbol available in Microsoft's public symbol server. So the stack trace that you get when you are debugging any Office application, it's actually broken. So in this experiment, I wanted to, kind of show you if you can somehow fix those. So I have found out a tool. So I'm going to do some experiment with that. So this is also my first time I'll be trying that tool. So I'll show you how does the broken stack trace look like. So I'm opening Windows Microsoft Office and I'm attaching it to that process 1084. Okay, so now I'll set a couple of breakpoints just to show you the stack trace. So I'm setting a breakpoint at create file A first. It is actually fetching the symbol. So yeah, create file A and create file W as well. Now I'll continue the execution and I'll see if I can trigger any of those breakpoints. So I'm just randomly clicking. As you can see, we have got a trigger for create file W. Now I'll show you the stack trace. So the stack trace is huge, as you can see, and is still busy actually. And now if you look at the stack trace, you'll be able to figure out the function ranges, right? They are actually huge. So these are basically these are not real stack trace. These are broken since it was unable to resolve those symbols for the function that are present in between. It is showing some some values there, but these are actually not real stack trace. So when you are actually reversing stuffs, it is really difficult to kind of figure out what's going on inside the application. So let's see if we can resolve it somehow. So I have found out a nice tool. I'm going to try it for the first time. So the tool name is fake PDB. So as you can see, it says tool for PDB generation from IDA Pro database, and these are actually LLVM based project, so probably you'll have to download LLVM. It's going to take some time. The first step is to compile LLVM with PDB support. After that, we compile that application using CMake, and we have to copy that content to the plugin directory of IDA and export information from IDA database. We have to execute, and it is going to give us a JSON file. So I believe the JSON file will have that IDA generated symbol name and the offsets. Most probably we'll see it, and we'll have to generate the PDB after that. So filename.exe to pdbgen.exe, it will generate filename.pdb near filename.exe. Okay, let's try it. So first we need CMake. We can close it. So let's open our VM first. So I have already created this working directory, and it's already there, I believe. Yeah, okay, we are already inside. So now we'll start with fetching the LLVM project. We have to clone that. Welcome back everyone. So let me tell you what just happened. So I have been struggling to build LLVM on my VM, but I could not do it because it's a very intense procedure. So as you can see in this Stack Overflow post, it is uh, this is the error that you are going to get probably if you're trying to compile it on a VM LD terminated with signal L. So it is because of extensive consumption of RAM. So these are the available solution. I tried this last two, but I could not increase I did not try to increase the swap disk size. So that's why I decided to compile it on my main system. But meanwhile, what just happened, that's very interesting. So I was trying to check out this repository again on my main system, and meanwhile what I saw that this repository got updated 2 hours ago, and I went to this release tab, and what you can see here, this precompiled binary of fake PDB gen is just released 2 hours ago. So if it was there in today morning, it would have saved a lot of my times anyway. So I'm going to try with this precompiled binary that they have released 2 hours back. So let's try it. This is first time for me as well, so things may not go right all the time. So it's going to be a bit long video, so please bear with me. So let's get started. First, let's try to find out those DLL. Let's collect those DLLs so that we can, give IDA to disassemble it for us. So we'll just windbg. I'll try to get the name again. Winword.exe, and as usual we'll set a breakpoint at create file. This is just a sample stack trace that I'm going to show you. Kernel 32 create file w. Let's try to trigger. If we just click on it, yeah, we can see that we have a breakpoint hit. Let me just maximize it a bit so that, yeah. Yeah, so if you just scroll up, what you can see, we need we can try with this one. We see 3 entries for this one. Okay, no, wwlib should be good enough. Let's see, where can we find this? Let's do lm wwlib. Here you go, and this is wwlib.dll. Okay, version is up to date. Okay, if you just I can just search it here, I guess, wwlib.dll. There could have been an easier option to do that actually. Okay, modules, wwlib. wwlib. You can just open file location, get it from here. Yeah. So let's try to disassemble it. wwlib. Paste it here, and we'll put it on IDA. You can just cancel it, we don't have it. Okay, mso.dll. Symbol server, it is not going to find it, so I'll just press no. Now it's going to take some time. It's pretty big deal. And meanwhile, what I can do, I can download this fake PDB from their GitHub repository. I think we already have it. Yeah. Yes, it is there. So I can just copy it from this folder and put it here. There is some connectivity issue, I believe. Let's okay, the fake PDB is okay. Now what we'll have to see, we'll see how are they recommending it to use it. So PDB file generation, open target executable in IDA Pro, edit fake PDB. So copy content of fake pdb.zip to IDA directory plugins. So the entire thing I have to copy to plugins directory. Let's see where we are with this. Oh, it is still going on. So after that, what we'll have to do, open target executable in IDA 7, edit fake PDB. So we are mainly interested in this strip, so I don't think we need this. So we just need that PDB file. So let's see how long does it take. So meanwhile, I'll just copy paste this tag trace in a text file so that we can, compare it later on with the new stack trace. And so let's keep it here as stack trace before symbol fix. Let's keep it here, and again it is going to take some time. So the IDA Pro has successfully loaded that www.lib.dll for us. So I'll have to, since I have added that plugin in plugin folder, I'll have to close it and reload it again. Okay, so www.lib64. So we'll have to go here, edit fake pdb generate pdb file, edit fake pdb generate pdb file. So I'm not really sure whether it has something is going on behind the hood or not. I think it is just trying to generate that pdb. Okay, we have this JSON file. Yeah, I think it is going on. Okay, we have this JSON file, but I'm not really sure where is that pdb file should stay. What it says, edit fake pdb, get the pdb from the IDA database directory. From the IDA database directory. generating desktop www.pdb. It says www.pdb, but I don't see this file. It says generating pdb file is done. I'll close it once. Let's see if I can. No, no pdb file. Let's try it once again. Edit fake pdb, generate pdb file. But I don't see any pdb file. That's the problem. Can't find the JSON file. I can see. I don't know what is wrong. I may have to go to P. Okay, we can, let's see if we can try it. pdb generate exe file path. I don't have exe, so I'll just give the dll file path. www.dll. This is going to be the dll file. The JSON file path also I'll have to give. So output file I can give like www.pdb. Let's see if we can find it, if we can generate it like that. Okay, it says it has. Okay, we have this pdb file now. Okay, let's now try to load this. Okay, so this is the one. We'll just keep it here. Now we'll have to do couple of things. So now actually what we have to do now, we'll have to forcefully load that symbol into this. So before we do that, I'll just save this stack trace. Okay, so this is the stack trace without symbol fix. Now let's try to fix the symbol. We have this pdb file here, fake pdb. Okay, let's do it. So we need to add it like this. So this is the command we are going to execute first on Windbg. Let's do it. Sympath response. Okay. Now we'll have to. Okay. So as you can see, the PDB is successfully loaded from this particular path. So we are good. Now one more thing you have to do. You have to disable the integrity check. So how you do that? Okay, fake PDB file. Okay, now let's try to dump the stack trace again. Okay, excellent. So what you can see here, if you look at the stack trace, right? We have successfully, since we don't have this symbol for other, haven't exported the symbol from IDA for other libraries. But if you look at this, right, we have this IDA function names right over here. So www sub and all these things. So this actually gives, a lot more visibility to, how this call trace is going on, which function is calling which function. So now if you just try to compare it with the okay, now I'll just copy paste this part only. Now this is our, now I'll just remove these things. Now let's have a look now. This stack trace look, very different. So we'll ignore this, but if you look at this, right? So now you can see all these functions that are in between this IDA function, you can easily trace back. Now you can directly search, although we didn't have Microsoft symbol, but we have, we have successfully fixed that broken stack trace. So our experiment was successful, and the tool did work pretty well, what I feel. So earlier what I used to do, I used to write a Windbg plugin for that. I used to export this symbol in a text format. After that I had a plugin for Windbg. So I used to load that plugin in WinDBG and parse that text file and manually add those, not manually, programmatically add, populate those symbol in the symbol tree of WinDBG. So but the thing is, this tool actually makes this a lot more easier, make that process a lot more easier. So that is awesome. Okay, so that's all I wanted to show you guys in this video. It was first time for me as well, and it did work pretty well. So thank you for watching. If you like the content, please do subscribe to my channel. And because every week I try to upload my experiments related to reverse engineering and other stuffs on this channel. So thank you for watching. Bye bye.